everybody, I'm back, and as you can see, I'm inside the bonus quiz for 3.8, a pretty demanding quiz, in that the first question itself has two parts here and deals with the idea of total profit function, which I covered in this video quite extensively. I'm not going to uh, replicate that whole thing. I think that's worth watching. But the second problem deals with simply one page in the entire section, and basically that page is the foundation of economic theory, supply and demand curves, and an idea called an equilibrium point. So we'll talk about that a little more extensively than we will this first problem. Now, here is the template for the derivation of a profit function from revenue and cost. In function notation, it looks like this. Now, C of x represents the cost of producing x widgets. So it's money going out from a firm. And R of x, revenue, represents the amount of money you make from selling x widgets. So this is incoming and this is outgoing, and it makes sense that when you subtract those two, you would get the total profit. So this first part, they're asking us to find the total profit function, is really a substitution problem. We're going to substitute in the rule for R of x and the rule for C of x and simplify. And when we do that, we have to be careful because there's a moment when things can go awry, and that's the idea of, well, the first substitution is easy. R of x is equal to this. And then it says subtract all of the cost function. So I have minus parentheses in the two terms that define the cost function within those parentheses. I need to subtract both of them. So I have minus parentheses here, and you know that that's a sign changer. And when we do that, we end up with this. P of x, the profit function, is this. Notice that the plus 500,000 now becomes a minus 500,000. And we have like terms here. We are driving for simplest form, so we combine them. And there is our profit function. And that is indeed represented over here as answer B. But check out answer A. It's very similar, except for the sign here. And you know, that's MathXL is doing the same thing I do on my multiple choice exams. It's giving you a chance to get it wrong, or giving you a challenge to prove that you really understand the techniques involved here, that you need to subtract the entire cost function. If you don't have these minus parentheses, you're going to end up with a positive 500,000, and you're going to think it's A. So we're fine-tuning the exam to really show that you know what you're doing, and that's a good thing. Now, as for the second part, I suggest that you don't use the profit function you found here to find the break-even point. I think you go back to the idea that we have a system of equations up here. We have a line here. Notice the slope is 25, and we have a line here. Notice the slope is 75, and because the slopes are different, we know that those lines are going to intersect. And the intersection, if you want to game the system, whenever you have two lines and they're asking you for a particular point, they're almost always asking you for the intersection point. Well, let me show these two lines. And you might not be thinking that you have the classic system of equations that you've been trained on earlier in this chapter, where you would have y on the left side and x on the right side, or you'd put these things in standard form and you'd solve by substitution or elimination. You might not see that the left sides here are in fact the same. But keep in mind that we're talking about the cost of producing X widgets and the profit made from producing X widgets. That's what the cost function and the revenue function are measuring. So I could rewrite this like this. The left-hand side is really just money. And so, we really do have a system of equations in two variables. In this case, I have x and m. Or if you want, you could use y. But the idea there is we have a system of equations, and we want to know where the break-even point is. That is when the cost and the revenue are the same, and there is no profit. And so all I need to do really is to solve this system. And so I'm just going to replace money down here by what it's equal to up here. I want to use a substitution technique and put that right there. And when I do that, we're basically back with one equation and one unknown. We're back in section 1.3. And can we solve that? Oh, I'm sure we can. We've done it many times. and I'm not going to walk you through it. Solving for x, I get x is equal to 10,000. So that's the quantity of widgets you need to make for there to be no profit. You make one more, you're going to have a profit. You make one less, you're going to have a loss. So it's the break-even point. And again, it's an ordered pair, so we need to follow through. And we need to find out the total cost here, the money involved. We know there's 10,000 widgets. Well, what's going to be the amount of money involved? And so you could sub that into either one of those equations. I think the second one, 75x, is easier. And when you do that, you get an ordered pair. And this is going to be the answer there. So that is the answer to problem one. Pretty involved. And let me go ahead and tell the machine I want B. And we're talking here about $10,000 and $75,000. And so let me just put in 75,000, 750,000, excuse me. And so let's go on to the next problem here.